All right, this is a continuation of the first video, just to kind of refresh what we just talked about. This is number 16 from your practice, which is asking you to find all the zeros of this function. So if I would look at this, I would realize there's no greatest common factor. It's not one of those special cases. It's not quadratic form. I've got 5 terms, so really not much of a way I could group this. So this would be basically one of those where I'd have to just find a few zeros. Now it would be helpful of knowing the table again. And so if I count my sign changes right now, there are 1, 2, 3 sign changes. So I'm going to have either 3 or 1 positive real zeros. And then if I change the sign on the negative powered terms, now it goes positive, 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 negative, negative. There's 1 sign change, which means there has to be 1 negative real zero. These would be my possibilities. So what I'm going to do is I'm going to try to find that first negative real. I could check -1 using that original equation, so it would be -6, +6, 24, and -40. And if I do this synthetically, this is not looking good. That's not going to work. If I try -2, again, I'm trying to find that 1 negative real zero. Oops, that should be a +24. And it works. And now I'm left with a cubic equation there. And I have found this 1 negative real. That is -2 is one of my zeros. Looking at this, I don't know if this would probably group, because I do have 4 terms. I don't think grouping is going to work. And so I'm going to kind of search and see if I can find the positive real for this. So what I could do is I could just start right away with what was left off. I'm going to check +1. And that's not going to work. If I check +2, and using those values that I left off with after I found the first one, and you can see that it does work. And so I found that 1 positive real, and I'm left with this quadratic, which I'm going to find out does not factor. And so if I would use the quadratic formula, the discriminant would be 36 minus 4 times 1 times 10, which is a -4. I'd have 6 plus or minus that all over 2a. That's the same as 6 plus or minus 2i over 2, which is the same as 3 plus or minus I. And those would be my 2 imaginary zeros. So I've got 1 negative real, 1 positive real, and then a couple imaginaries. All right, the last part of this practice is asking you to write a polynomial function that has the given zeros. So let's say the zeros are -1, 2, and 3. Now we've learned that if -1 is a 0, then x plus 1 would be a factor. And if 2 is a 0, then x minus 2 would be. And if 3 is a 0, x minus 3 would be. So I've got all the factors here. And then what I would do is just multiply those. So I'm going to take these two. I'm going to FOIL it. So I'm going to have x squared minus 2x plus 1x minus 2. Combine those like terms. I would have that. And then I would need to multiply this by that next remaining factor, which is the x minus 3. So I'm going to distribute. I'm going to have x cubed minus 3x squared, negative x squared. I'm going to keep those like terms together. Positive 3x negative 2x, and a positive 6. And then combining like terms, I'd have x cubed minus 4x squared plus x plus 6. That would be the function or the equation that has those three zeros. Now, if one of the zeros is imaginary, so this next example I'm saying that 2 is a 0 and 3i. But we've learned that these imaginaries must come in pairs, so therefore I must have negative 3i. Now, my factors would be this. I'd have x minus 2, I'd have x minus 3i, and then I'd have x plus 3i. And then again, I would multiply these together. I'm going to multiply these because they both have the I in there. So x times x is x squared. And then I'm going to have 3ix. Don't panic because I'm going to have negative 3ix. So those are going to cancel. And then I'd have a negative 9i squared, which remember we learned that I squared is a negative 1. And so basically this is x squared. Those cancel, plus 9. And then I'd have to take this times the x minus 2. So I'd have x cubed. I'd have a negative 2x squared. I'd have 9x. And I'd have a negative 18. And that would be the cubic equation that has these three zeros. So next one I've got negative 3, and then I have 2 minus I. So I would need to have 2 plus I. So then my factors would be x plus 3. And then I'd have x minus 2 plus I. So I'm doing the opposite. And I'd have x minus 2 minus I. I'd multiply these together. Now don't be intimidated because a lot of this is going to cancel. So this would be x squared. I'd have negative 2x. I'd have a negative ix. Then I'd run the negative 2 through. I'd have negative 2x plus 4. And then a positive 2i. Run the I through, I'd have ix, negative 2i, and then a negative I squared, which is like a negative 1, which is a positive 1. So you can see those terms with the i's cancel, and I'm left with x squared minus 4x plus 5. I'd have to bring this down, and I'd still need to multiply this through. So distributing this x, I'd have x cubed minus 4x squared plus 5x, and I'd have 3x squared minus 12x plus 15. Combine those like terms, and this would be the cubic equation that would have these three zeros. So I hope this helps you with your finishing up the 6-7 assignment. You should do problems 2 through 6, 2, 4, and 6, and then 12 and 14, and then 17 through 20, which are very similar to the ones that we just did here.